Hello, everyone. My name is Márton Braun. I'm a developer advocate at JetBrains, working on Kotlin, Kotlin multi-platform, and all of the related technologies. And today, I want to talk to you about composing an API the right way. So this is a talk about Compose API design, because I truly believe that all of us are API designers in Compose, ultimately, as we're writing Compose code. Of course, depending on what kind of projects you work on, this might matter more or less for your use case. If you're building something really foundational, something that's more like a framework that a lot of other people are going to call into and build on top of, then it's more necessary to strictly adhere to the API design guidelines for Compose. The same thing goes if you're a library, and if you're just building an application, you are still an API developer because your colleagues are going to use the APIs you create. You are going to use the APIs you create, ultimately, but you can probably be a bit more loose about how you build those APIs. Yeah, so it's a scale from being like a framework developer to working on application code. Now, this talk is going to be a summary of a couple documents by Google. These live in the Android X repo. These are very long documents. They're great reference material with a lot of technical detail. They also take a couple hours to read, so I'll try to give you some of the highlights here in about 40 minutes. Of course, if we take a look here, all of these say Jetpack Compose, which is what Google is working on, but it's going to be no secret that anything you learn here will also apply to Compose multi-platform, which is being built by JetBrains on top of Jetpack Compose, expanding the use of the same APIs and the same UI implementations to different platforms. A bit more specifically, here's the currently supported platforms and their stability. So on Android, we are reusing Jetpack Compose as is. On desktop, it has been stable for quite some time. And if you use JetBrains Toolbox, that's actually a Compose application running on desktop. And then recently at KotlinConf, we have moved iOS to beta and web to alpha. So those targets are also taking their steps towards stability. A quick overview so that you have some expectations for this talk today. First, we're going to talk a bunch about naming. Then we'll inspect parameters, which are a very important topic in Compose. And finally, we'll deal with a bit of state handling. So let's talk about naming first. The first convention that Compose breaks with is the naming for constant values in Kotlin. So if you take a look at the regular Kotlin API guidelines, you would use this shouting case, which we have inherited from Java static values, right? But with Compose, this is not how we name constants. Instead, what Compose does is it uses camel case with a capital letter at the beginning for naming such values. And they actually do this across the board, regardless of whether it's an actual constant value or just something that's equivalent semantically. So they do the same thing in Compose for regular values, which refer to just one specific object that is stable over time. They also do this, of course, for actual objects in Kotlin. And they also do this for enum values, which, again, is breaking with the default convention of how enum values are named. But they are doing this for consistency, so because on the use side, you shouldn't really care about whether you're grabbing an object from somewhere or you're grabbing the value that's stored in a property. You just want the behavior and the semantics to be correct. Let's talk a bit about functions then. So we've just seen how properties are named and how we are breaking the usual conventions there. What about functions in Compose? Is there anyone who can tell me how we name composable functions? Just shout it in. OK, that's a mix, which kind of works, because the answer is that it depends. So generally speaking, there are two kinds of composable functions. We have functions that emit content, and we have functions that return a value. And never the twain shall meet, so there should be no overlap between these categories. For things that emit content, which are composable functions, we have examples like all of the UI functions that you are used to, rows, layouts, buttons, and so on, as well as things like launched effect. Generally speaking, these are functions that emit something into the composition. They add nodes to our Compose composition. And they kind of look like constructor calls with this uppercase naming. And that works because whenever we call these functions, whenever we hit the code path in Compose where these things end up as part of our composition, we are essentially creating a thing. So it's fairly close to making a constructor call, if you think about it. You might also notice that all of these are named as nouns. So it's a column, it's an effect, it's a thing, it's some kind of entity that exists in our application. On the other hand, we have composable functions that return a value. So here you can see that the naming convention is different. Now we're using lowercase naming for these. And here you can think of any number of functions, but for example, something like string resource would be a composable function because it needs to use things from the composable context, like the current locale of the application and so on. But it's not creating a thing that lives in the composition, it's just producing a value and using the composable context. And the same goes for all of the remember style functions, such as remember scroll state. We can dig into these kinds of functions a bit more. Something that exists in Kotlin is this calling convention for functions that create an instance where you call the function the exact same name as the type that you're returning. This is something that's in the Kotlin guidelines, but with Compose you actually shouldn't do this because, once again, this is actually a different type of composable function. So to indicate that this is not something that creates an entity in the composition, these should be lowercase. And this especially applies if you're also doing something other than creating and returning that value. For example, if you are already remembering the value for the caller as well, then you should prefix that accordingly. And again, that should start with a lowercase. All right, at this point, I want to define a component in Compose. The two guideline documents I've mentioned previously use 2 or 3 different terms for roughly the same thing, so I'm just going to consolidate all of those into a single definition here. And I'm going to say that a component is something that's a composable function, which returns unit, and emits exactly one Compose UI3 node. And we're going to take a look at each of these parts of the definition. So let's talk about why you want a composable component to return exactly one node first. Generally speaking, whenever you're writing Compose code, you are creating a tree structure with this. So here, for example, we can map the snippet that you can see on the slide to this tree structure. You can see that we have the column at the root of this component. Then it has 3 children, text, text, and row, and so on and so on. And one of the great things about Compose is that you are just writing Kotlin code. So whenever you need to refactor something, those are regular Kotlin refactoring steps. So for example, if you want to reuse some part of the Compose code, you can take that and move it into a separate function, right? And then instead of having those text calls directly in the previous function, we can just call the new function that we have created. However, you do have to be a bit careful about how you do this, because now we have created a new composable component which doesn't emit 1 node into the composition, but it emits 2 nodes, which can lead to certain types of problems. For example, it's quite easy to now call this function somewhere else, and then you realize that because it's not really self-contained, it kind of expects to be called within a layout where these texts originally were called. Now your layout could get broken, for example. So composable components should really be self-sufficient, and you should be able to reuse them in different places in your code base. So for that reason, you should make sure that they have a single root node. For example, in this case, we can just wrap our texts into a column layer. And then, of course, we'll fix our rendering issues as well. Going back to the definition, the next thing I want to take a closer look at is why these components should return unit. If you're coming from a more imperative background, which a lot of us are coming from before Compose times, it might make sense to you to create functions that also return some kind of handle that you can use to then interact with the component. For example, you might want to create an input field like this, where it will render something in the composable UI, but it also returns a state, which is an object you can interact with. For example, on a button click, you might want to use that to clear the state of the input field. This presents multiple problems, the first of which is the problem of split responsibilities over who owns the state here. So the input field has returned us this state object, which means it created it, and it probably has full access to that object as well. So in theory, it could easily modify and update its own state. But it also gave us a reference to the state, so we also get to control it. But we don't have full control over the component because it also has this reference internally. The other problem that this introduces is a simpler code level problem, which is that our code is no longer independent of ordering. For example, let's say that we wanted to move this input field that's returning a state below the button on the UI. So we just wanted to swap these 2 things around in our code. Of course, we could no longer reference the input state in the on-click listener of the button, because now that gets returned from a function call, which will happen right after the button call is created. So to avoid these kinds of issues, it's really better to drive components with external state. So instead of having them return a handle to their state, we want to pass in the state, and then the component's responsibility should only be to render that state onto the UI. This way, we can pull that state to whatever level is appropriate in our application. We can move it around. We can scope it as high as we need so that everyone who needs to have access to it can have access to it. It's completely up to us to manage that state. And of course, we no longer have ordering issues either. We can freely move around our code now. And if we need to do something like some validation whenever we want to make changes to that state, we now have the power to do all of that as well. So that's the general way how Compose components should behave. They should take data as inputs, and they should transform that into UI. And the main way that Compose functions take data as inputs is, of course, going to be parameters. Before we talk about various types of parameters, though, I first want to talk about the alternative to parameters, which is using composition locals. We're not going to do a deep dive here and look at the specific APIs. I just want to talk about the general concept. You can learn more about composition locals on the link on the slide, and I'll also have all of the links collected on the last slide for you. So composition locals are a way of exposing data to a subtree within your composition. For example, let's say that in this node, we provide a composition local value. In that case, anything that's under that in the call hierarchy and the compose tree will have access to that same value. So any of those nodes can just reach out and find that value in the composition without having to receive it as a parameter. Looking at the guidelines, they tell us that it's OK to use this for styling purposes, which is really a global concern in applications when something like the language of the device changes or light and dark mode changes. We do want all of the components in our UI to be notified of that and to be able to update themselves. But we should not use this to pass down data conveniently. So just to avoid having additional parameters in our composable functions, we should really make sure that we use parameters for that, and we only use composition locals for global concerns such as styling. So in general, explicit parameters over the very implicit workings of composition locals. This also, again, makes sure that all of your components are reusable in your application, so they are not tied to being hosted under like one specific subtree of your UI where composition local happens to exist for them to use, but they can be used anywhere as long as you pass in the correct parameters. All right, let's explore parameters next then. One of the things that Compose makes really heavy use of is default arguments in Kotlin. This is great because it allows us to have components which offer a lot of customization. They have tons of parameters for us to customize their behavior, but they can also be called by providing just the required values. For example, in the case of the text composable, all we have to pass in is a string by default. And then if we want to adjust how this text will be shown in the UI, we can start providing more parameters. One of the nice use cases for styling with composition locals is using those values as default values for various parameters. This way, the component can pick up the styling that's coming from the composition local values. But if we locally want to change how the component behaves, for example, give it a separate text style, we can still pass in our own value by just overriding the value of the default parameter. Something similar that you might end up doing is this kind of solution, where instead of referencing the default value from a composition local directly, you might be tempted to use a marker value, like a null value. And then if no value was passed in, then in the implementation somewhere, you go and resolve that into a composition local instead. This is something you should avoid, generally speaking, when building a Compose API. Instead, null should only be used to signal that you really don't want to provide that value, so it shouldn't be this kind of placeholder so that it will get resolved to something else with a fallback. Null should really signal the absence of a value, which is what happens in the button composable, which is a really nice example of using a null value as a default parameter, because buttons don't have a border stroke by default, so the default value there is null and it's used correctly. But if someone does want a border on a button, they can pass in a value for that, and that will be used by the implementation. Looking at this signature here, we can also see another convention here, which is if you have a lot of default values for your component, it's nice to collect these into a separate object. In the case of a button, there is a button defaults object, which contains various functions to create button-related types, like the button colors or button elevation type, as well as just having some default values, like the default shape or the default padding for a button. If we take a look at that object, we can see that these are indeed all collected there. Some of these can even be composable functions so that they're aware of any values provided through the composition. And the benefit of having this nicely collected is that users of the component can also reuse these default values in certain cases. For example, if you have a button, and in some cases you have some custom colors available that you want to pass in, but in other cases, you want to fall back to the defaults, you no longer have to copy some specific hard-coded default value on the right-hand side of that Elvis operator to fall back on. But instead, you have this convenient button defaults object exposed to you, and you know that whatever is the default implementation for this value is what you're going to get if you reference that. So you can use your own value or fall back easily to the defaults. And you can also do similar things for your own components if they have a lot of default parameters. Something important here is that you should make sure that these default values are accessible, because that's the entire point of creating them. Even though minimizing APIs is a very, very good idea in general, for these default objects, you should aim to make them public so that they can indeed be reused. Next, I want to talk about modifiers, which is going to be the first of two of my favorite Compose features. Modifiers allow us to easily customize components without having to expose dozens and dozens of parameters on every composable function. So by taking just a single modifier parameter in a component, we can allow various kinds of customization for sizing, for setting colors and padding and clickability and accessibility and so on. So this is really convenient. And because we have modifiers, something you should avoid doing is providing extra parameters for things that are already covered by modifiers. For example, because we can already adjust padding using modifiers, your components should not provide a padding parameter, which takes the same value and overrides modifiers, or modifiers override this. It's a confusing API. Something else you might ask yourself is whether your composables should take a modifier parameter. So let's take a look at what happens if you don't offer that parameter to your users, but they want to customize your component in some way. What they can do then is they can just wrap your component with something simple like a box and then apply any modifications onto that component. So if your page title didn't allow setting padding and background, they can just wrap that in a box and provide the same customizations on there. So the only difference between not providing a modifier parameter and providing a modifier parameter is how convenient your component is to use, but you're not really preventing its customization in any way by skipping this. So in general, you should provide a modifier parameter, which is going to be one of the first modifier guidelines that we list here. I'm going to list a bunch of others, and then we'll take a look at them in detail. So this parameter should be named modifier. That one is fairly self-explanatory. It should be the first optional parameter of your function. It should be applied to the root node, and it should default to the value of uppercase modifier. So the first two we've already seen and looked at. We're going to get back to ordering parameters in a couple of minutes here. So let's take a look at why a modifier should be applied to the root node first. So the root node of your component is whatever function call, whatever composable function call you make at the root of the function. In this case, for example, we have this header composable, which has a couple simple layouts in it. And as you can see, we are correctly applying the modifier in this case because we are passing that along from the parameter into the column, which is the root of our composable structure here. In comparison, this would be an incorrect use of a modifier. And the problem with not applying the modifier to the root is that the customizations that your users pass in as a parameter, they expect those to apply to the entire component that you have. So if you look at this component from the outside, it's essentially a column, right? Because that's at the root of the component. So whenever someone adds padding to your component or sets a background color on it, they expect that column to gain that background color or that padding. And if you apply your modifier to just some subtree of your component, then it's not your whole component that gets customized, but just parts of it, which is really unexpected behavior. So for that reason, you should apply it to the root. Now, this isn't always a single place within your composable functions implementation. Because, for example, based on conditional logic, your composable function might have different roots. Here we have a function which takes a Boolean parameter, and depending on whether that's true or false, it either arranges some pieces of text into a column or into a row. So we can see here that it's correct to apply the modifier parameter twice, in a sense, because only one of those cases will ever happen when this code executes. So whether it's the column or the row component here that ends up being the actual root of your component, that's what the modifier will be applied to. Next, let's talk a bit about why we should default to the value of modifier and how that works under the hood. So you've already seen me use this on all of the slides so far. We had a default value for modifier. And what that points to by default is actually the companion object of the interface, which itself implements the modifier interface. So it used to be in early versions of Compose, back in like early 2020 and before, that we had a separate modifier.non object that we could use for an empty modifier. But then they've realized in the API design that they can just use the companion object itself. They can get a bit more concise code, and this can already serve as an empty modifier. So if you don't pass in an actual value and this default value gets used, this represents no customization. You can safely apply this to the root of your components always, and it just doesn't do anything by default. You can even see that something like the then function in this companion, which combines it with another modifier, simply returns the other modifier because this one is not doing anything. So here we have an example of what else you can do with the modifier parameter, because it's nice that users can pass in their own customization, but you also want to sometimes apply your own modifiers to the root of your component. So let's say that you want some default padding to be added to the row that's the root structure of your component. In that case, you can actually take that incoming modifier and then chain additional modifiers on top of that. So this is completely correct implementation of a component. As the modifiers get applied last to first, all of your core customizations are going to be applied to the component, and then whatever your user passes in will be applied on top of it. What you should not do is the same thing the other way around. So you should not chain the incoming modifier parameter to the end of a modifier chain, or to the middle for that matter, because that way you're going to apply modifications around what the user passed in on the call side, which is going to override some of the things that they try to customize, and again, just lead to unexpected behavior on the UI. There's a lot more to talk about with modifiers, such as how the ordering works exactly and so on. So again, here's the link to the official documentation, which is also going to be on the last slide. All right, next I want to talk about my second favorite thing about Compose parameters and API design, which is slot APIs. When we talk about slots in Compose, we really just mean parameters which are composable functions themselves. These allow you to easily pass in UI as a parameter to a composable function, and then it can use it as part of its implementation. It can render the UI that you've passed in within the component itself. If you ever had to do this using the view system, you know that this is a very painful process, trying to pass in a view or a layout and then attaching that into an existing view and having all of that behave correctly. But with composables, this is actually one of the simplest things to do, which is great. So let's take a closer look at this. So usually, this would mean that users can call your component. If you place this as the end of your parameter list, you can use the trailing lambda syntax. So your component physically, visually contains whatever was passed in as UI as well. And for example, we can have a button which doesn't mandate what you can put on it. It's not just a text necessarily, but you can pass in arbitrary UI like an icon and a text that will be displayed on the button. You can also go a step further, and if you know that users usually have some kind of default frequently used layout that they pass in. For example, with a button, we often want to put multiple things next to each other, like icons and pieces of text. Then you can actually provide that layout for users by default. And you can do that by creating the layout within the implementation of your function. So here, the internals of the button function could already create a row, and then take a function that will be called inside that row. And we can indicate this by using a receiver on the composable function. All of these composable layouts like row, column, and box create their own receiver scopes, which indicate that the content inside them is part of such a layout. And this can, of course, be seen on the call site as well if you have something like inlay hints enabled. And this way, you know that whatever code you're writing down there will automatically be placed into a row, so you don't need to wrap it in a row yourself. This also gives you access to things that are only possible within a row. So for example, we have a weight modifier, which can tell a row layout how it should size different components in relation to each other. And this can only be called when you're inside of a row. And this is also provided by the row scope context that we have here. You might be wondering here if this is an incorrectly implemented composable function here that we're passing in on the bottom, because we are now creating a composable function with a lambda here, which doesn't have a single root, but it has multiple nodes that it emits into the composition. And the reason why this is OK to do in this case is because A, we're not defining a component here. We're creating a lambda which is only used in a single place, so we don't want to reuse this in any way. And B, of course, we have that receiver on the lambda, which already indicates that we're going to be in a row, so we can safely emit multiple things into the composition, and we know that they're going to be laid out side by default anyway. Something interesting to consider when you're working with slots is the lifecycle of the content that you're passing in. Here, I have a component, again, which takes a Boolean parameter, and based on whether that's true or false, it's either rendering some things into a row or into a column. And as that's happening, if we draw up a timeline here, the preference item itself exists for quite some time, but then the content that you've passed in as a parameter might exist for a certain amount of time in one of the two possible layouts. But then as you start changing the state of this checked value, for example, you change it to false and then true and then false again, every time that that happens, as we go from one branch of the composition to the other one, all of the content that we have already created for one of the branches gets dropped from the composition, and we have to call the content function again, recreate that UI just to show it in a row or a column or vice versa. So there is a very specific API which is designed exactly to solve this kind of problem, which is movable content off. What this allows you to do is wrap your original incoming content function into movable content off, which you should then also remember. And instead of calling the original content function, you can call this function in multiple places within your composition. For example, here we can call it on both of the branches. This way, whenever the Boolean state changes and we switch from one branch to the other, the content will not be recreated. It will only be created the first time. And the second time that it's called somewhere else, the nodes in the composition will just get moved to somewhere, to the other location. There's a great article exploring both this and the slightly more complex movable content with receiver off function, which I can recommend if you want to dive a bit more deeply into these topics. All right, let's talk about ordering parameters, which I've also promised earlier. So here, again, the guidelines give us a couple different rules that we can combine. So they say that we should first have the required parameters for a component. Then we should have the optional parameters. And again, the first one of those should be a modifier. And if we have a primary slot that we're taking as a parameter, we should call that content. And it should be the last parameter of the function so that we can make use of Kotlin's trailing lambda syntax. Let's take a look at a composable function and apply all of these requirements to it. So first, required parameters should be at the top, right? So we can take all of the required parameters, except that last one, because that's actually going to be the primary slot parameter. And we can move the required parameters to the top. The reason why that's important is because we want to be able to call a composable component by default by providing just its required parameters, just like we've seen with the text composable, which you can call with just one parameter, and then add additional things for customization. This would currently not work because we are passing in parameters by position. So the first parameter would have to be a modifier, which we may or may not want to provide. Of course, One fix is to put the required parameters on the top of the parameter list. An alternative fix, which you can do either way, is to use name parameters, but you don't want to force your callers to always use name parameters, so it's important that you also get the ordering right. Of course, in cases like this, where, for example, we're passing in a Boolean value, which is not super readable on its own, it's still a good idea to name them as the caller, but you shouldn't force that as the designer of the component. All right, next we should have optional parameters on the list, and the first one should be the modifier. This is already correct. So here, all I want to mention is why it's important that modifier is the first optional parameter. And this is really about conventions, as all of this API design topic is, because if we all follow the same conventions with our components, then if you have experience with existing components, like the built-in foundation and material ones, and we also build other components with the same guidelines in mind, then we know that we can have these same expectations towards these components. For example, in the case of modifiers, once we've already provided the required parameters for a component, we can know that anyone following these guidelines have put modifier there as the first optional one. So without really thinking about it or having to name the parameter, we can just pass in one more parameter, which is a modifier, and that should always work as long as everyone is following these same guidelines. All right, finally, again, we should have the primary slot, if there is one in the component, as the last parameter. Has this beautiful trailing syntax. And the only thing that we have to fix here is that by convention, this should be called content. So with that, we have managed to patch up this function signature, and now it adheres to all of the guidelines that we have. For the last topic today, I want to talk about different aspects of state handling with composable components. So first, I want to take a look at this signature and ask the question of whether it's a good idea to pass in a mutable state object into a component. This is going to be a quick answer. This is a bad idea, which is, again, because we are splitting responsibilities and we're muddying the ownership of this state. We have access to this state as the caller of the component, and we can modify it externally. But if we pass in the mutable state to the component can also modify the state, so we have essentially lost control over it. And if we want to do validation or we want to veto some state changes, we're no longer able to do that. So a better approach is to pass in state that the component can use to render the UI, and then give the component a way of communicating back to us that it wants to change the state. For example, we can do that with a callback function like this. Another question we can ask here is it a good idea to pass in the current value of the state as a composable state object? So this one is read-only, unlike mutable state. So this should be safe, right? Because it doesn't have the problem of the component changing its own state. It is safe in that regard, but we are complicating the lives of whoever is calling the component. Because let's say that they already had a float value from somewhere, and they're just trying to pass on that float value to your component. Now that you're taking a state as a parameter, you are forcing everyone to wrap whatever value they had, wherever it came from, into a state object, just to call your component. So for example, in this case, they would have to maybe create a mutable state, put the value they already had in there, just so that they pass it into your component, and you can read it from that state. So for all of these reasons, it's really best to take just plain values as parameters. The one exception to this is that in some cases, it might be desirable to, instead of the plain value, take a function that can produce that value for you. This allows the most flexibility for your callers because they can call your function in many different ways. They can pass in a hard-coded value, they can pass in a plain value that they already had from somewhere, and they can also read either composable state or state from any arbitrary objects in the application. This can also come in handy for performance optimization reasons, because if you're not passing in the existing value, but you're passing in a function that can produce the value, then maybe some state reads can be deferred and the value can be computed less often than you otherwise might have to if you just passed in the value to begin with. And there is, again, a great article that I'll point you to at this point, which talks about debugging recomposition and how it can be beneficial to use deferred values passed in as lambdas so that you can improve the performance of your application. For the last thing I mentioned today, I want to talk about state holders. So as you're creating your components, we've learned that it's nice to have the parameters passed in as regular values, and then have the component and then give the component the ability to signal back to the caller that it wishes to make changes to these values. Eventually, though, as you're adding more and more parameters like this might get convoluted, and you might want to simplify the component. And one way to do this is to introduce a state holder. For example, we can create a state holder interface like this one, which contains the two values that the component was working in. It can have both of these in there as just mutable properties. And then we can, instead of the 4 separate parameters, we can take one of these vertical scroller states as a parameter. As you can see, there's a naming convention in play here. The state holders should generally have the same name as the component itself with the state suffix. These components should, state holders should also be stable, which again, we're not going to get lost in the topic of stability here, but this means that whenever their internal state changes, they should notify the composition. This generally means that these properties should be backed by mutable state. And so far, we only have an interface, so let's also give our callers an implementation, and we're going to use exactly mutable state for this. So we're going to create an implementation class, which implements the given interface, and it just delegates each of the properties into a mutable state. Now, we can make this a bit nicer, because right now, callers of our component have to instantiate this slightly ugly named state holder implementation class to be able to use our component. So we can provide, for example, a factory function for this, which returns the interface type and hides the implementation class completely from our callers. And we can make their lives even easier by introducing a default value for the parameter. So we can just remember one of these scroller states by default, and then they can call our component without any parameters, but they also have the ability to customize if they want. Now, we started off this slide by trying to solve the problem of having 4 parameters for a function. And now we have maybe 15 lines of code and some complexity introduced. And if you're building a framework or a library, this is still a great approach, and it's how you should do this. The interface also allows anyone to implement the same state holder with perhaps different implementations. They can wire it into a data source, for example, or anything like that. So this is great for flexibility and great for libraries, but you don't necessarily want to do this if you're just writing application code. So in an application code, the same thing could easily be achieved by just creating a state holder class like this, which directly can be used, and it can have mutable state stored as each of its values. And of course, if you change your mind and you do end up needing multiple implementations of this, you can always just grab this, extract an interface from it, and start building multiple implementations. And that brings me back to the first point that I made during this talk, which was that these guidelines apply more strictly if you're building foundational code, if you're building libraries, if you're building the core modules of your application that 100 other Android developers are going to build on top of. But if you're writing things that are closer to the leaf nodes of your application, so things that others are not really building on top of, you can feel free to deviate more from these guidelines. There was a Google I/O talk earlier this year on the same topic, which I want to give a shout out to. This also covers some of the same aspects, but also some important details about planning your components and maintaining your components over time. So I recommend checking this out after this talk. And so that we talk a bit about tooling here, there are also a great set of static analysis tools, which can be used with k2lint or detect, which can enforce various things that are part of the guidelines. So for example, making sure that your function either emits or returns a value, or the ordering of parameters, this collection of lint rules can ensure that you are following those guidelines in your code base automatically. So that was composing an API the right way. Here are all of the links that I've mentioned along the way. Thanks for joining this talk. I don't know if we have time for questions. We have time for one question here. And importantly, I'm going to be at the JetBrains booth probably all day and tomorrow for the majority of the time as well. So you're very welcome to visit us there as well. And yeah, thank you.